Good afternoon, everyone.
Good afternoon.
Shri Squinder Singh Ji Tami, Director, Chairman, Sparkle Ceramics, Chief Speaker for the day. Shri S.S. Patnaik, Director, NITTR Chandigarh, Deans, Professors, Heads of various departments, faculty colleagues, staff members, and dear students. I welcome you all for this inaugural lecture series, which is basically comprising of a number of lectures. We have planned around 75 on self-reliant India, which is being planned at ITTR Chandigarh to celebrate the 75th anniversary of our independence under the dynamic leadership of our director, Professor S.S. Patnaik. I request Professor Patnaik to address the audience and share his ideas about this series and his vision about this series of lecture on self-reliant India. Professor Patnaik, please.
Directly at the outset, namaskar to Dr. S.S. Dhami. In fact, morning we had a confusion whether it is our own colleague Professor S.S. Dhami or somebody else. And since I was out of station, so I was clarified that it is a very dynamic personality who was given a lot of inputs to the country in terms of the piezoelectric materials, and I was told that your company under your creative innovations is taking care of our country's need.
Absolutely.
So it is a great news being from Punjab, and the good news is that our colleague Professor S.S. Dhami is also a relative of yours. So we are not having that wrong information. So it is not the speaker S.S. Dhami, but definitely our colleague S.S. Dhami is directly related to you also. So that's a great news, and thank you so much that you could find some time out of your busy schedule to address us. The idea was that when I discussed this matter with Rupinder ji, I told him that look, engineering areas are so vast. There are many areas where we are still demanding the interference of engineering colleges and polytechnic. The big issues are generally handled by the IIT or NIT systems, but there are colleges around us, the polytechnics around us, who can contribute significantly, but somehow they are not part of this big theory. They can be very well part of the contributions which the society is looking forward to, or which the society is not brilliant yet. Let's find out those 75 topics, start inviting these people who can give thought process or create a vibration among the mind of our engineering and polytechnic students, so that with the support of the infrastructure available in our good colleges and polytechnic, those issues can be addressed. If not today, by tomorrow, we should be self-reliant in that direction. So, and we can accumulate these 75 thoughts in a document, and this document can be also circulated among all these participative institutes, even those institutes who are not directly linked today, so that they can also explore, they can start working on this, and finally the country should move towards to this direction where you are contributing significantly. Similarly, if 75 such topics are handled, and we'll have a lot of contribution for our country. So it has a long way to go, but this is the start, and I'm happy that we are starting this particular thought process with a great personality like you. And this institute is a institute which is in existence for last more than 50 years. We started way back in 1967, being the trainer for the teachers. We are supposed to give also this type of thought process among the mind of our teachers, who can invoke this particular culture, this particular of entrepreneurial approach among our students, so that one day our country's requirements are met within our country rather than depending on outside the country. So that is the basic objective. With this motto, we really wanted to start these 75 lectures. And I request my colleague, actually this is an institute which we are having mixed group, like many professors are there who are in the not that old like ours. There are also people who are seasoned, almost all verge of retirement in another 5 to 7 years time. But this particular institute has a lot of potential, and with this type of 75 topic addressed by a personality like you, can drive the ecosystem for meeting our this objective of giving message to the country and the students and teacher of engineering and polytechnic college that look, the present facility is also good enough to meet the requirement of the country. So that's the basic objective, and with this word I thank you once again, Professor Rupinder and his team, for arranging this type of eminent experts to address our thought process. Hopefully, the accumulation of these 75 lectures will give a good food for thought to the colleges, mainly the engineering colleges and polytechnic, to carry forward the mission of Atma Nirbhar Bharat, Swabalambi Bharat, and self-reliant Bharat. Thank you so much.
Thank you.
sir, for your words of wisdom. Let me give the brief introduction of our speaker. Mr. Sukhwinder Singh Dhami, graduate in mechanical engineering, BE from NIT Warangal in 1991. He joined Sparkle Ceramics Private Limited as a director in 1991. Then after that, he completed his MBA in finance from Pune University in 1999. This company in which he is working, this is mainly working on the area of piezoelectric sensor element which are based on lead, zirconate, titanate in 5 principal grades. The company was founded by his father, late Shri G.S. Dhami. He retired as scientist F from ARDE Pune, and who was instrumental in introducing this technology of PZT and bringing the same to the production scale. Nowadays, we talk about technology readiness level 7 to 10. So just see, in 1991, they have done this and introducing the same primarily for the armaments and underwater application. He has been instrumental in developing the export market for piezoelectric sensor elements, and as a result, this Sparkle Ceramic Private Limited is exporting around 30% of its annual production to the key customers across Europe, UK, US, South America, Russia, Israel, Australia, and Asia. Since 2011, he has been engaged in scaling up the production of PZT composites and establishing the manufacture of large-scale element, which is weighing up to 1 kg. This has helped the company to get a name in military and defense application. The company is aerospace certified since 2021. The key area of interest are TQM, lean manufacturing, optimizing production process, engineering of PZT compositions, and technology upgradation. He's a member of American Ceramic Society and life member of Powder Metallurgy Association of India. So with his wide experience in this field, let me request Shri Dhami to start his proceeding. Sir.
Thank you, Dr. Rupinder Singh, for the brief introduction and also giving me an opportunity to speak. I would also like to thank Professor S.S. Patnaik, Director, National Institute of Technical Teachers Training and Research, Chandigarh, for giving me an opportunity to present our journey of self-reliance, where our company has substituted the imported products in key areas of defense and military applications. And rightly, as Professor Patnaik is saying, and also it is his vision, how this can be a movement of self-reliance. And I would also say on key technology matters where technology is involved, it is very important for the next generation to really take up this challenge, and I believe we can do it, just as the way we are beginning on the way of manufacturing semiconductor chips on a very large scale. So with these words, I will give you a brief presentation of our company. So our company, Sparkler Ceramics Private Limited, basically is making piezoelectric sensor materials. Now, I know I don't want to get too technical into it, but just briefly, piezoelectric comes from a Greek word. Piezo means pressure, electric means electrical output. So if I apply pressure, I will get an electrical output. Or in simple terms, I'm converting mechanical energy to electrical energy, or vice versa. The simple application we can consider is the domestic gas lighter, which everyone is using, and we are lighting the gas. So the gas lighter is we hit a pin, the pin goes and hits a piezoelectric element. It's a very small piezo element, about 5 millimeter diameter and 10 millimeter long. On impact, this generates a high voltage pulse. 12,000 volts is typically, that's how it jumps the spark gap, and sufficient energy to ignite the gas. So that is a very simple application of piezoelectric elements and materials which are going for gas lighter application. This is a very high-tech area, and our company has been successful in taking the technology to a production level close to about 1 metric tons. So I'll come to that details, but I'll give you a background how it actually started. So the topic which was given was Ayat se Atma Nirbharta ki or. And in this, I'll try to give a brief journey of sparkler ceramics in the self-reliance, indigenization or import substitution of these materials which were coming into the country. So of course, the pioneer has been my father, late Shri Gurcharan Singh Dhami. He retired as Joint Director, ARDE, which is Armament Research Development Establishment, Pune. It is an organization coming under the ambit of DRDO, which is Defense Research and Development Organization. So as you can understand, it is Armament Research Development Establishment. He joined in the mid-60s when he relocated from, he was teaching at Karnal University as a lecturer. My father has done MSc from chemistry from the Punjab Engineering College, Hoshiarpur Honours School. Later on, he started teaching at Karnal University, and then he got this opening at DRDO, where he continued till his retirement, and then founded Sparkler Ceramics Private Limited. So, as I can tell you, armament research was developed, basically doing armament research. So, if we can see, I'll just try to show you picture. At that time, if you can see this is a 84 Carl Gustav gun, which typically used to be mounted on the jeeps for firing rockets, etc. So in this gun, in the ammunition round, there is a piezo. The ammunition round consists of a fuse, and in the fuse, there is a piezo element. Now, this piezo element was actually being imported, or we had to import these ammunition. Now, the sensor element was typically of Matsushita, Japan origin at that time, mid-60s, I would say. And some material would be coming of Russian origin. So the seed of indigenization or making this material in India came from the specific need that there is a requirement for using it in this product. So once the need has arisen, then of course you dream about making the materials. So my father started working in the material called lead zirconate titanate. Thoda complicated hai, it is a bit complex. But in short form, we call lead as P, Z, zirconate is Z, and T, titanate called PZT. Now PZT was just introduced in the world in the late 50s. Now in this sense, my father did a lot of pioneering work that he was not lagging behind in development of material, just a 10-year lag, or I would say 10 to 15-year lag when these materials were already developed. So he started working primarily for making the materials for the fuse application. And again, as you can see, these are the ammunition rounds in which the nose portion, the fuse element is incorporating a piezo element. So when the projectile is fired, on hitting the target, the piezo element gets crushed. It develops a high voltage pulse, which sets off the detonator, or for explosive round gets exploded. Typically, these rounds would be fired at tanks also. It would be fired at armored carriers to destroy the enemy armored carrier or possibly enemy tanks. So the background was in mid 60s and the materials were manufactured. And my father says, he used to explain to me at ARD, we would not have all the facilities. So the composition, it is, so I'll just give you a brief idea. This is the typical manufacturing flow chart of the piezoelectric ceramics. Typically, we weigh a lot of materials, जो formulations हम बोलते हैं, then you mixing, oven dry, इसमें some heat processes, then we grind the powders to a predefined particle size, उसके बाद हम forming करते हैं, and then there is sintering to get the sintered component, then you do grinding, उसके बाद हम electrodes apply करते हैं, और फिर हम polarization करते हैं. Polarization जिस तरह similar, this is called electrical polarization, just like हम magnetization करते हैं, similar है, इसमें temperature time profile आता है, and then we do the testing. So testing के जो parameters आते हैं, based on that, the materials, once they made the first material, they took it to Ahmednagar range, they assembled the fuse and they fired the round, and it was successful. So they achieved almost 85-90% success within a very short period of time. And the director of the establishment of ARD was very pleased, and he approved setting up of the piezoelectric pilot plant to start manufacturing piezoelectric elements principally for these applications. So the journey started there, I would say in mid 60s. Around mid 70s, the Navy people also, उनकी requirement आती है. So naval application में आप ये देख सकते हैं, there is a sonar. Sonar क्या होता है कि sonar underwater radar होता है. जैसे एयरक्राफ्ट का ओवरहेड रडार होता है कि जो एयरक्राफ्ट को ट्रैक करता है, तो सोनार इज समथिंग which is an underwater communication system. So sonar is nothing, sound, navigation and ranging, where the sound is produced by the piezoelectric element. अब आप ये पिक्चर में देख सकते हैं कि सबमरीन बेसिकली ऊपर का शिप is trying to detect the enemy submarine. तो शिप के ऊपर जो the sonar is there, it will send out the waves, and enemy submarine से reflect होके the ship is picking up. और signal analysis से you can come to know this is an enemy submarine or which type of thing it is and how far it is located away. So Indian Navy के जो भी sensors बन रहे थे, whatever sensors were coming were principally of Russian origin. So they also gave this project to ARD कि you should indigenize making these materials for the Indian Navy. So Navy के जो the research body or the one which makes the entire sensor is called Naval Physical Oceanographic Laboratory at Cochin. And फिर उन्होंने they took out all the samples that can you make the product. I think within 2 to 3 years, these materials were also developed and successfully introduced in the Navy. But despite that, the production of the items were not coming to a production level because government laboratory the. So in 91, in 93, my father took premature retirement. I'll come back. Sparkler was established in the year 1990 and my father took premature retirement in 1993. Sparkler, we were doing multiple products, जिसमें piezo was one of the products we started in 1995. And we started producing these materials for various applications. Of course, Navy के लिए भी और defense for the armament, जो anti-tank ammunition में जाता था, we started producing the materials in production quantities and supplying to them. But still the Navy was importing क्योंकि जो sensor assemblies would come from United States and the sensor integrating establishment is Bharat Electronics Bangalore. So we started giving them samples, they started working on indigenizing the sensor. But still no one was taking a decision that we will go 100% indigenous they would continue to import. But what happened in 1999, जब इंडिया ने second Pokhran blast किया, lot of these sensor imports came under embargo and the countries denied the sensor technology because they had the defense application. Now this became a boon to our company because our products were already approved, but decisions were not being taken to use the Indian products into the system. Now with the Pokhran blast, हमारे products they started using on a large scale and introducing it into the Indian Navy for underwater. And this journey from there, I mean, it was, मैं ये नहीं कह सकता हूँ that we were perfect in the beginning, but Bharat Electronics helped us, handled us, and we improved our products. Initially, only we were to global standard, but within a matter of few years, our product was as good as the ones which they were getting from United States. And with great pleasure, I'll inform you, most of the Navy Indian systems incorporating the sensors, all the product is coming from Sparkler Ceramics currently. We are the sole supplier to Bharat Electronics and Indian Navy. However, certain systems may still be continued to be imported because NPL, the research agency, is working on new designs, benchmarking with the best in the world, and we are working on many other projects. So this is the journey. Briefly, I will just how we started, how we have got entry, and now we are an established player in the defense sector. After that, of course, we became member of American Ceramic Society. We are member of the Electronics and Software Export Promotion Council since 2014. And it is important that we started exporting in 2003. And as we say, हम जो बोल that we should be self-reliant, Atmanirbhar. I believe that manufacture local but global. So आपका proof of pudding is if the best customers in the world are using your product, it becomes a badge that the Indian product is as good as the others in the world. And this is really जो हमें ये recognition मिला from a lot of the suppliers abroad. This has really established us in this area. So, key grades, I will just run you through the brief presentation. This is different grades हम जो बनाते हैं. ये process हो गया. ये कुछ material grades के parameter हैं, but these are technical. I wouldn't want to get into this. जो notable applications हैं, हमारी material space applications में जा रहे हैं. Besides for gyroscopes, missile में there is a gyroscope which is used. We are supplying to India and we are also exporting to Israel. Israel Aerospace Industries are using Sparkler piezo elements for the gyroscopes going into the Barak missiles and other missiles. Of course, they do not tell us the details, but my father has given a presentation in 2010 in Israeli Aerospace Industries. We continue to supply to them, having displaced the UK supplier at Israeli Aerospace Industry. We are now the principal supplier to them. Our materials were also going into nuclear reactors for measuring the liquid sodium sensor level जो उधर जाता है. Naval military applications I've already explained, जो defense में fuse जाते हैं. And micro steering of antenna, ये भी ISRO का project था where we supplied the piezoelectric materials. जैसे मैंने already explained किया, we are supplying for hydrophone, sonar, depth finders, atom profiling, ammunition, rockets, gyroscopes, etc. for missiles. Automobile में जो applications इसके हैं, it is going in force transducer, जो wheel balancing. Many of our cars हम जाके wheel balancing करते हैं. The computerized wheel balancing uses a piezo sensor for sensing the unbalanced force. So this is a common application. which at least we are familiar with the car जो हम wheel balancing करते हैं. Of course फिर engine के knock sensors, fuel atomization, ultrasonic reversing mirror. तो cars के पीछे जो हम reversing कर रहे हैं, this is a ultrasonic reversing sensor based on piezoelectric material. Medical applications में ultrasonic nebulizer modification करता है. And many times जिसको अस्थमा होता है, we go to the doctor, तो वो nebulization करते हैं. This is also using piezoelectric materials. Ultrasonic health and therapy products like ultrasonic physiotherapy, ultrasonic fetal heart detector, ultrasonic imaging medical में, flow meters, fluid sensors. And roughly हमारे जो materials हम बनाते हैं ये various shapes में आते हैं. This is the sensor element will look like this. It could be a ring shape, various shapes and sizes. These are some applications. I'll come back. And disc shape भी हम बनाते हैं, various sizes. ये इसको हम sensor element बोलते हैं. And cylindrical shapes, hemispherical shape, dome shaped है, and assembled hollow balls हैं. This also we are exporting to Russia. The Russians have substituted their materials with the Indian material, but we don't have the exact details because our customer, जो हमारा distributor या Russia based है, वो आगे किधर supply कर रहा है, कैसे supply कर रहा है, we do not know the details. But हमें, we are quite sure it is going into the defense applications. Russians are using our materials there. Of course, हमारी quality system is now to the US DoD mill standard है, और अभी हम aerospace, we are also aerospace certified. These are our quality management systems. Our manufacturing capacity is currently 1,000 kilograms and may be going up to 2,000 kilograms per month. It's about 24 tons per year. So, Sparkler participates in a lot of exhibitions. In fact, हम Ceramic Expo USA में जा रहे हैं अभी towards August end, and we will be participating in Electronica in Munich, Germany. Now, the objective of Sparkler going to these exhibitions is that there is a company, Sparkler Ceramics, that can make these materials in India. The same quality world over. Currently, 30% of our entire production हम export कर रहे हैं. There is no third world requirement. All the requirements are coming from advanced developed countries like Europe, UK, inside China, Australia, Israel, USA, Canada, South America, etc. And जैसे if you see the self-reliance story, Mahatma Gandhi also started when he said we should make khadi at home, and the charkha started. So the concept of self-reliance, I also believe कि I always tell my team कि आप product ऐसे बनाओ, strength. Sparkler ceramic should be seen globally from the point of view of strength. And once we have the strength, we will get the respect. And there will be the foreign manufacturers who will say that we want to tie up with you and we can partner with you. That is my global vision, that ultimately the foreign suppliers may want to set up base, shake hands with us, and we can do some joint ventures in due course of time. So currently, हमारी manufacturing is from, we have a new facility almost measuring about 2 acres, and we are ready to increase our production should the market, we further the market and add more customers to it. We have got class 10,000 clean room, lot of facilities. These are some of the facilities which we have. And we are currently working on very key projects for the Navy, for flank array for submarines, for the nuclear submarine. A lot of the project details I can't share with you, but we are the principal supplier of these sensor elements, and it feels really satisfying that we have been able to give production scale quantities at an economical price in a time bound manner. See, one happens, you make the product, you made in India, but are you competitive? Now, we can make these materials, but if it is so costly that customer will not pay you, again, it's not of any use. You made a product, but you cannot sell it because your manufacturing cost is very high. So both things are very, very important in the self-reliance journey. One of the journey, you can make it costlier, but in due course of time, if you want to sell your product in the global market, you have to be globally competitive. Globally competitive, but जो China mass manufacture करता है, we are not in that area because China has actually reduced the price to below cost of production for certain gas lighter के जो piezos हैं. The Chinese was supplying it for 50 paise. उसका price has become 1 rupee 50 paise. And gas lighter जामनगर में 7 रुपए में बन रहा है, 7 rupees, and they are able to sell the gas lighter even in the global market because the cost of manufacture is so low. They can compete with the Chinese. And I also believe we can also compete with the Chinese if we have the right ecosystem. And of course, these are some pictures of our facilities, our team, our staff, some of the processes. ये पुराने pictures हैं. Now, I don't have the latest picture, but shortly we'll be having the newer pictures also of our newer facilities. So, इसमें भी मुझे ये एक आता है, the gull, Jonathan Livingston Seagull का जो quote है, the sea sees the furthest who flies the highest. So, in this indigenization journey or of self-reliance, first we have to think it in the mind, we have to dream it, then we have to live the dream, and we have to be able to see dur se and start working in that direction. Now, today I may be feeling very happy, but when my father started the journey, I joined in 91 in Sparkler. It took me about 20 years to understand the complexity of the technology. And after my father passed away, unfortunately in 2011, I've been handling it and managed to build on the base and increase production and understand the complexities of production further. And my vision is to take Sparkler ceramics to a global scale. And we are headed in that direction. Of course, if we have the right thing and the right team, we'll be able to do wonders. So with these words, thank you. And
Sir, can you ask some questions? Yes, sir. बोलेंगे, Nirbharta जी बोलेंगे. Questions. Sir, can you ask some questions?
Thank you, sir. Thank you for the wonderful talk. So there are a couple of questions some audience want to ask, if you allow, sir.
Sure, sir.
अमित सर, आप मैं स्पेसिफिकली आपके SP5A के बारे में पूछना चाह रहा था. शायद ये PZ5A के इक्विवेलेंट ही होगा आपका.
हाँ जी, होगा.
तो अगर मान लीजिए फॉर एग्जांपल अगर 1 मेगाहर्ट्ज का क्रिस्टल है आपका, λ/2 थिक होगा, तो आप इसका पोलराइजेशन करने के लिए इसको कितनी वोल्टेज पे और कितने टेंपरेचर पे आप पोलराइज करते हैं? मतलब शायद 1 किलोवोल्ट के अराउंड मतलब रहता है, तो टाइप मतलब फिर तो टेंपरेचर का वो एक वेरिएबल बन जाता है, कितना टेंपरेचर पे रखते हैं आप उसको पोलराइजेशन.
Yeah, so polarization can be done from 100 to 140 degrees in different mediums. It is a process which has to be optimized to get the required properties. Provided your composition and formulation is right, if it can withstand the polarization, temperature and field, you'll get the result. So basically हम क्या करते हैं? We optimize the pooling to get the results. और अगर हमारे results सही नहीं है, then we have to work on the formulation or composition.
ओके सर, फॉर एग्जांपल सपोज मैं उसको 15 वोल्ट देता हूँ आपके क्रिस्टल को,
हाँ,
तो आप मतलब कितनी कॉस्टिक पावर मुझे मिल जाएगी?
या सो पोलराइजेशन का क्या है, बिफोर वी पोलराइज उसका D33 जो चार्ज कोएफिशिएंट है वो 0 होता है. पोलराइजेशन के बाद जैसे 5A का मटेरियल 500 तक जाएगा. So if we don't reach near 500 480 means or it is low, we come to know हमारा polarization नहीं हो रहा, या तो because of polarization or formulation difficulties या formulation optimum नहीं बना है, और processing जो बोले.
ठीक है, ओके, थैंक यू सर, थैंक यू.
Okay, thank you.
Okay, anybody else want to ask some question? Sir, I have 1-2 queries, if you allow.
Sure, sir.
We were working on this PVDF based piezo crystals.
Okay.
So we are also blending some barium titanate into this and graphene, something like
Yes.
that. And at Nitter, we are working on some 3D printing of these type of piezo crystals, and we are getting this around 56 picocoulomb per Newton as.
Okay.
So just is there any possibility from this Sparkle ceramic side that we can have a industry institute interaction and can go for the development of the product?
Yeah, see, actually, the development of PVDF, actually, if you see, a lot of the Scorpion submarines, the sensors were based on the PVDF design. NPL has been working on PVDF, but they have not been successful. I don't know, someone has gone and taken training. So if we can actually develop something in PVDF, we'll be happy to work with you and to take the technology to a working. And see, all this works well, we have to see an end use in front of us and a customer willing to work with us and willing to start this journey, then we can go along with them. So I'm happy to work in the area of PVDF, since there could be a requirement from in the Navy itself.
Okay. So right now our focus with PVDF is mainly for some implant application for getting
Medical. Okay.
Specifically in veterinary, that way we are exploring.
So that also is fine, but PVDF being lightweight, very flexible, reduces a lot of the mass in underwater. Only problem is it's not too sensitive, requires high-tech electronics. But the flexibility, now we are trying to replace PVDF systems with piezoelectric, piezo composite systems. जो trials चल रहे हैं, but it makes the system bulkier. So there are 2-3 types of technologies there: PVDF, fiber optic technology, and PZT composite technology. Each has its limitations. What works out best, they are trying to evaluate.
Great.
We'll be happy for medical application. We'll be happy to see how we can work together. And if your system is proven up to a certain stage, we can take it to the production scale also.
Great, sir. That will be great for us if we can go for TRL 7 to 10. And
Okay.
That's really good for us.
Yourself, you're working on this area?
Sir, our department is working in this area, yes, definitely.
But this surprises me. Y'all are the National Institute of Technical Teachers Training and Research. Plus, you'll do research on products also independently and
Yes, sir. We have all engineering departments like mechanical, civil, computers, electronics. So we can train teachers only once we are trained ourselves in technology. No? We have to be updated that way.
Okay, can I say something?
Yeah, please go ahead, sir.
See, y'all are the professors, very senior people. I also at one time was a student at NIT Warangal. That time it used to be called Regional Engineering College Warangal. So jo fluid mechanics ke hamare professor, he was there. He used to say, I used to tell him my father is in piezoelectric materials and this, that. And he asked me a question that can you give us a piezoelectric crystal? Now, as students, it surprises me that till that period, although we were taught, we never knew what was a piezo element. Neither the teacher or professor showed us what is an element, what is a piezo crystal, quartz. So my suggestion, I can only give a suggestion to a lot of the faculty, is we need people to think, students to think, innovate, rather than too much emphasis is given on rote learning. Ratta maro, 100 out of 100 lado, grade point average, 8.9, 9.9. But practical knowledge, do they have practical working knowledge? So project-based learning should be more encouraged, even at BTech level, or even at teaching at school level. So I will exhort ki from there, once the ideas come to the mind, people know a basic working direction. If they get some ideas, they know how to work in that direction.
Yes, sir, that was great, sir. At NITR, we are actually trying for that purpose only. We are having the master's and PhD program running over here. So basically, we are more in the research part that way. Professor Bus, I think he has a question.
Sir, I wanted to ask a simple question. What are the three plus points for India to be a self-reliant country, and the three hurdles which are there in this path?
Acha, the main hurdle, I think, is in the mind. That it is very difficult, we cannot do it, or how can we compete? Just self-created blocks in the mind. Now make simple. I talk to you about piezoelectric materials. I will give you a simple product like humidity storage cabinets, जो for storage of critical electronic components हैं. A company like Godrej makes cupboards of good quality. Why can't they make humidity cabinets and supply to the world? I think one biggest problem is a lot of manufacturers do not want to work below 40% margin, 30% margin. And the Chinese are willing to work at 10% margin, 5%. But the Chinese are saying, we will make for the world. हम बनाएंगे but पूरी दुनिया में बेचेंगे. And really, China का success story, if I tell you, is simple. They have made technology affordable. एक raw material which we were importing from UK or Europe, $25 a kg, $30. China started giving $10 a kg to it. And I'm not saying cheap, good quality, Reliance, which even we can do. Constraint सिर्फ हमारा thinking का है कि हम कर सकते हैं. We give up before, and I think we can compete with China on any product. Indians just have to have that. हमारा थोड़ा culture, discipline of commitment चाहिए. थोड़ा laziness हम निकाल देंगे mind का, and we start working. I think country can do. Limitless talent है in the country. Lot of the talent दब जाता है. It doesn't come to the surface because of the way we are working. We don't try to. It is natural that we don't try to promote. If someone overpowers me or becomes my boss, how will I allow it? So this fear कि वो overperform करेगा. These are so lot of the obstacles are in the mind, and I can tell you many companies are now taking product to the global scale, and there are many people across I see who have shunned the traditional systematic way of working, proper working. और एक और जो प्रोडक्ट होता है, प्रोडक्ट अच्छा भी दिखना चाहिए. Chinese were very good in packaging. So first point, it appeals, it sells. But second, does it work for the long term? So there are Chinese suppliers whose products won't work for the long term, but they will work for the long term. There are other suppliers whose product is costlier. So you have both segments, cheap product, medium quality product, and good products coming from there, addressing all segments of the market. And I think even India can do it. If we get over, we have the right ecosystem. Now, just to elaborate, IIT Madras, they have set up incubation centers, and they're promoting small industries to take their ideas to a production level. Such things happening, even I think in Punjab Engineering College, they have probably set up these incubation centers which allow people to give birth to the ideas and to make the product. Now, more such collaborations, etc., will take place. I'm sure we will do many things, and we can compete at the global level. So, fact is, manufacture local, sell global. If you can sell globally, your product quality issues are addressed and your competitive pricing issues are addressed because you can sell at the global level.
Sir, what about government policies? Are they supporting our cause of becoming self-reliant?
100
Presently, ease of business and government policies, how they are working in favor? Are
government.
these in favor or still there are some gaps there?
No, I wouldn't say that. See, if I showed you the slide, we started exporting first in 2003. This was directly through internet. And in 2006, I went for a participation Latin America. Export Promotion Council focus government of India का scheme था that please exhibit in South America, वहाँ exports बढ़ाइए. And do you know cost of exhibiting और जाने आने का return fare government reimbursed? It was unbelievable. Of course, I had to spend it upfront. I still remember it was close to 1.5 lakh, including hotel stay. My booth charges were refunded by the government. That allowed me to go, but I had to spend initially from the pocket, and then the Export Council say, "मैं refund मिला." Now government has done, and even Electronica, which we are exhibiting in November, it is through the Export Promotion Council. We get a subsidized booth at 2 lakhs. If I go directly, it is going to cost me 5 lakhs or 6 lakhs. So this is the government support. Government कर रहा है, आप जाओ, आपकी प्रोडक्ट रेडी होनी चाहिए. आप चले गए और प्रोडक्ट दे दिया बट फेल हो गया, then the customer will not come back to you. That is very important. Once we are ready, then you try to present to the world and get to the customer. It's a journey. And I remember one of the directors जो Cosmo Ferrites के थे, he has a plant in Himachal Pradesh. He was exhibiting and he told me, "Dhami sahab, you are coming here, don't bother but participate without break continuously. आपका कस्टमर आपको देखते जाएगा, आपका कॉम्पिटिटर्स देखते जाएगा, and they will note about you." And it has been my personal experience that you get noted, then you supply the product, that gets noted, and it helps you in the long journey. So government is helping. They are giving you MIDC, जो industrial development, जो states के होते हैं, they are giving you land at subsidized price. If you go to buy it at market rate, it might be costlier. थोड़ा बहुत वहां से सपोर्ट है. एक्सपोर्ट प्रमोशन में हमें थोड़े बहुत इंसेंटिव मिलते हैं, हालांकि कंपोनेंट लेवल वी हार्डली गेट अबाउट 1 to 2%, बट इट इज स्टिल गुड इनफ. वी गेट GST सेट ऑफ. सो आई थिंक वी शुड डिपेंड लेस ऑन doles. Government is doing more than enough. Lot of thoda we have to also do a lot of hard work from our end. Government is there to help us. Lot of schemes are there. Promotion, Focus India. I will say there are n number of schemes, and if you can use them, you are able to succeed. Provided, of course, आपकी product has to come up to that level. See, we do benchmarking. You should come at least to 90 to 95% level, which makes your product acceptable to the customer, and he is willing to supply it. Even today, at any of the project, when in the tendering they tell us that you're the sole supplier, we can import it. And I tell them, if there is a foreign supplier willing to supply you at X price, 100 rupees, we will give you 10% less than that price. No question asked. It has to be a reputed supplier. So we match them on that front. So government का support काफी है. Government can do little more, but they are trying their best. So they've introduced this production-linked incentive scheme to speed up manufacturing on the larger scale. Component level पे आया है, but generally not applicable to us. For us, issue is of getting the market, of finding the market. For us, issue is not of manufacturing, but getting a market. I can grow if I get more customers in the global arena. मुझे constraint growth का I can grow as per the market demand.
Thank you, sir. Thank you so much.
Yeah.
Thank you, Dhami sir, for this wonderful talk. This is really great to understand that somebody here is the sole supplier for Indian Navy and BEL. This is really good, sir. And as a Atam Nirbharta self-reliant India, we are helping our country for the import substitution. And really thankful to you that you have a hand-holding, you assured the hand-holding to us for Industry Institute interaction for developing some technology and going up to the technology readiness level 7 to 10. Thank you very much, sir, for sparing your valuable time and coming to us and enlightening us about your journey and how you actually come up with this Atam Nirbhar and self-reliant India scheme. Thank you once and all for this discussion. Thank you very much.
Thank you, Dr. Rupender Singh, and all the people at NI, National Institute of Technical Teachers Training and Research. And thank you for bearing with me this glitch of the speaker. Generally, I did a last presentation at College of Engineering, Pune. वहाँ मुझे problem नहीं था, but somehow today this was a problem. Thank you for bearing with me and helping me out. And I wish you all of you very best. And also, I will wish on the occasion of Independence 75th year, all of you a very happy Independence Day. And may, as in the director Patnaik's words, may this propel the journey and vision of Atmanirbhar Bharat in critical technology areas. With this, I thank you once again for giving me an opportunity to speak on this platform to all of you. And thank you for listening to me and hearing the story of Sparkler Ceramics. Thank you once again.
Thank you very much, sir. Sir, whenever you come to Professor Dhami over here, please come to NITAR and see our facilities also.
Sure, sir. Sure, sir.
Thank you very much, sir.
Yeah, thank you, sir.